What's good? So I'm gonna just be doing this refresher in Intro to SQL. I already took a course in SQL last summer, but just need to refresh my memory. So SQL, Structured Query Language, is a programming language designed to manage data stored in relational databases. SQL operates through simple declarative statements. This keeps data accurate and secure and helps maintain the integrity of databases regardless of size. The SQL language is widely used today across web frameworks and database applications. Knowing SQL gives you the freedom to explore your data and the power to make better decisions. By learning SQL, you will also learn concepts that apply to nearly every data storage system. The statements covered in this course use SQLite, Relational Database Management System. You can also access a glossary of all the SQL commands taught in this course. Let's begin by entering an SQL command. In the code editor, type select all from celebs. You will run all of your SQL commands in this course by pressing the run button at the bottom of the code editor. And we did this. We see our query results: Justin Bieber, Beyonce Knowles, Jeremy Lin, and Taylor Swift. Our schema, name. So our ID column has type integer, our name column has type text, and our age column has type integer. Relational databases. Nice work. In one line of code, you returned information from a relational database. Select all from celebs. We'll take a look at what this code means soon. For now, let's focus on what relational databases are and how they are organized. A relational database is a database that organizes information into one or more tables. Here, the relational database contains one table. A table is a collection of data organized into rows and columns. Tables are sometimes referred to as relations. Here, the table is celebs. A column is a set of data values of a particular type. Here, ID, name, and age are the columns. A row is a single record in a table. The first row in the celebs table has an ID of 1, a name of Justin Bieber, an age of 22. All data stored in a relational database is of a certain data type. Some of the most common data types are integer, a positive or negative whole number; text, a text string; date, the date formatted as year, month, day; real, a decimal value. Now that you have an understanding of what relational databases are, let's take a closer look at the SQL syntax. Statements. The code below is a SQL statement. A statement is text that the database recognizes as a valid command. Statements always end in a semicolon. So create table, table name, column 1 data type, column 2 data type, column 3 data type. Let's break down the components of a statement. Create table is a clause. Clauses perform specific tasks in SQL. By convention, clauses are written in capital letters. Clauses can also be referred to as commands. Table name refers to the name of the table that the command is applied to. Column 1 data type, column 2 data type, column 3 data type is a parameter. A parameter is a list of columns, data types, or values that are passed to a clause as an argument. Here, the parameter is a list of column names and the associated data type. The structure of SQL statements vary. The number of lines used does not matter. A statement can be written all on one line or split up across multiple lines if it makes it easier to read. In this course, you will become familiar with the structure of common statements. Let's take a closer look at the statement we wrote above. In the code editor, type select all from celebs. Run the code to observe the result and ask yourself which parts of the statement are clauses. What table are we applying the command to? So this is a clause. This is a clause. We're applying it to the celebs table. I guess, couldn't this all be considered a clause? Whatever. Oh, I guess I should have looked at that. Whatever. Create. Create statements allow us to create a new table in the database. You can use the create statement anytime you want to create a new table from scratch. The statement below creates a new table named celebs. Create table celebs, ID, integer, name, text, age, integer. Create table is a clause that tells SQL you want to create a new table. Celebs is the name of the table. ID, integer, name, text, age, integer is a list of parameters defining each column or attribute in the table and its data type. ID is the first column in the table. It stores values of data type integer. Name is second. It stores text. Age is third. It stores integers. Now that you have a good understanding of SQL syntax, we can create a new table. We've cleared the database from the previous exercises. Confirm no celebs table exists by entering the following in the code editor. So select all from celebs. Look at the results. The database should be empty. Now that we know the database is empty, let's create a new database. Let's create a new celebs table. In the code editor, type create table celebs ID integer, name text, age integer. We will learn how to view this table in a later exercise after we've added some data to it. Insert. The insert statement inserts a new row into a table. We can use the insert statement when you want to add new records. The statement below enters a record for Justin Bieber into the celebs table. Insert into celebs, ID, name, age, values 1, Justin Bieber 29. Insert into is a clause that adds the specified row or rows. Celebs is the table the row is added to. ID, name, age is a parameter identifying the columns the data will be inserted into. Values is a clause that indicates the data being inserted. 1, Justin Bieber 29 is a parameter identifying the values being inserted. 1 is an integer that will be added to ID column. Justin Bieber text that will be added to name column. 29, an integer that will be added to age column. Add a row to the table. In the code editor, type insert into celebs ID, name, age, values 1, Justin Bieber 29. Look at the database schema. How many rows are in the celebs table? 1 row. Add 3 more celebrities to the table beneath your previous insert statement type. So insert into celebs ID, name, age, values 2, Beyonce Knowles 42. Insert into celebs ID, name, age, values 3, Jeremy Lin 35. Insert into celebs ID, name, age, values 4, Taylor Swift 33. 4 rows now. Select statements are used to fetch data from a database. In the statement below, select returns all data in the name column of the celebs table. Select name from celebs. Select is a clause that indicates that the statement is a query. You will use select every time you query data from a database. Name specifies the column to query data from. From celebs specifies the name of the table to query data from. In the statement, data is queried from the celebs table. You can also query data from all columns in a table with select using asterisk. Asterisk is a special wildcard character that we have been using. It allows you to select every column in a table without having to name each one individually. Here, the result set contains every column in the celebs table. Select statements always return a new table called the result set. Let's take a closer look at select and retrieve all the names in the celebs table. In the code editor, type delete your previous select statement from the code editor. To select all the data in the celebs table, enter the following statement in the code editor. Alter. The alter table statement adds a new column to a table. You can use this command when you want to add columns to a table. The statement below adds new column Twitter handle to the celebs table. Alter table celebs, add column Twitter handle text. Alter table is a clause that lets you make the specified changes. Celebs is the name of the table that is being changed. Add column is a clause that lets you add a new column to a table. Twitter handle is the name of the new column being added. Text is the data type for the new column. Null is a special value in SQL that represents missing or unknown data. Here, the rows that existed before the column was added have null values for Twitter handle. Add a new column to the table in the code editor. Type alter table celebs, add column Twitter handle text, select all from celebs. And we've now added this Twitter handle with nulls. Update. The update statement edits a row in a table. You can use the update statement when you want to change existing records. The statement below updates the record with an ID value of 4 to have the Twitter handle Taylor Swift 13. So we update celebs, set Twitter handle equals at Taylor Swift 13, where ID equals 4. Update is a clause that edits a row in the table. Celebs is the name of the table. Set is a clause that indicates the column to edit. Twitter handle is the name of the column that is going to be updated. At Taylor Swift 13 is the new value that is going to be inserted into the Twitter handle column. Where is a clause that indicates which rows to update with the new column value. Here the row with a 4 in the ID column is the row that will have the Twitter handle updated to Taylor Swift 13. Update the table to include Taylor Swift's Twitter handle in the code editor. Type update celebs, set Twitter handle equal, where's the at character? At Taylor Swift 13, where ID equals 4, select all from celebs. And look at that. Delete. The delete from statement deletes one or more rows from a table. You can use the statement when you want to delete existing records. The statement below deletes all records in the celebs table with no Twitter handle. Delete from celebs where Twitter handle is null. Delete from is a clause that lets you delete rows from a table. Celebs is the name of the table we want to delete rows from. Where is a clause that lets you select which rows you want to delete. Here we want to delete all of the rows where the Twitter handle column is null. Is null is a condition in SQL that returns true when the value is null and false otherwise. Delete all of the rows that have a null value in the Twitter handle column. In the code editor, type the following. Delete from celebs where Twitter handle is null. Select all from celebs. Now there's just one row in the table. Constraints. Constraints that add information about how a column can be used are invoked after specifying the data type for a column. They can be used to tell the database to reject inserted data that does not adhere to a certain restriction. The statement below sets constraints on the celebs table. Create table celebs, ID integer, primary key, name text unique, date of birth text not null, date of death text default not applicable. Primary key columns can be used to uniquely identify the row. Attempts to insert a row with an identical value to a row already in the table will result in a constraint violation, which will not allow you to insert the new row. Unique columns have a different value for every row. This is similar to primary key, except the table can have many different unique columns. Not null columns must have a value. Attempts to insert a row without a value for a not null column will result in a constraint violation, and the new row will not be inserted. Default columns take an additional argument that will be the assumed value for an inserted row if the new row does not specify a value for that column. Create a new table with constraints on the values in the code editor. Type, so create table awards, ID integer, primary key, recipient text not null, award name text default, Grammy. ID, name, age, Twitter handle, that's our celebs table, and our awards table has ID, recipient, award name. Cool. Review, congratulations. We've learned 6 commands commonly used to manage data stored in a relational database and how to set constraints on such data. What can we generalize so far? SQL is a programming language designed to manipulate and manage data stored in relational databases. A relational database is a database that organizes information into one or many tables. A table is a collection of data organized into rows and columns. A statement is a string of characters that the database recognizes as a valid command. Create table creates a new table. Insert into adds a new row to a table. Select queries data from a table. Alter table changes an existing table. Update edits a row in a table. Delete from deletes rows from a table. Constraints add information about how a column can be used. So in this lesson we learned SQL statements that create, edit, and delete data. In the upcoming lessons we will learn how to use SQL to retrieve information from a database. What would be correct syntax for a create table statement? So create table, meals, name, text, rating, integer. What does the insert statement do? Insert new rows into a table, insert a new table into a database, insert new columns into a table, fetch data. I believe new rows. Yes, you can use insert statement when you want to add new records. What does SQL stand for? Structured Query Language. Which of the following statements is correct and complete? Delete from ice cream where flavor is null. What is the purpose of the asterisk character? It only selects columns, selects every column in the table. What is a relational database? A database that organizes information into one or more tables. Collection of data organized in one column, set of data values. Which clause is used with the alter table statement? Alter table, I think add column. You got it. What would you need to complete the associated update statement? Update something, set height equals 6 where ID equals 1. So update row. No, a table name. Yeah. What are common data types in SQL? You have integer, text, date, real. What is a null value? Value that represents missing or unknown data. Cool. Gonna keep it pushing. Introduction. In this lesson, we will be learning different SQL commands to query a single table in a database. One of the core purposes of the SQL language is to retrieve information stored in a database. This is commonly referred to as querying. Queries allow us to communicate with the database by asking questions and returning a result set with data relevant to the question. We will be querying a database with one table named movies. Let's get started. Fun fact, IBM started out SQL as SQL, Structured English Query Language, in the 1970s to query databases. We should get acquainted with the movies table. In the editor, type the following. What are the column names? ID, name, genre, year, IMDb rating. Select. Previously, we learned that select is used every time you want to query data from a database, and asterisk means all columns. Suppose we are only interested in 2 of the columns. We can select individual columns by their names, separated by a comma. Select column 1, column 2 from table name. To make it easier to read, we moved from to another line. Line breaks don't mean anything specific in SQL. We could write this entire query in one line, and it would run just fine. Let's only select the name and genre columns of the table. Now we want to include a third column. Edit your query so that it returns the name, genre, and year columns of the table. As knowing how select works, suppose we have the code below. Select name as titles for movies. Can you guess what as does? As is a keyword in SQL that allows you to rename a column or table using an alias. The new name can be anything you want as long as you put it inside of single quotes. Here we rename the name column as titles. Some important things to note. Although it's not always necessary, it is considered best practice to surround your aliases with single quotes. Note that this practice is specific to SQLite, the RDBMS used in this exercise. When you work with other RDBMSs, notably PostgreSQL, no quotes or double quotes may be required in place of single quotes. When using as, the columns are not being renamed in the table. The aliases only appear in the result. To showcase what the as keyword does, select the name column and rename it with an alias if you're choosing. Place the alias inside single quotes like so. Note in the result that the name of the column is now your alias. Edit the query so that instead of selecting and renaming the name column, select the IMDb rating column and rename it as IMDb. IMDb rating. Select IMDb underscore rating. Cool. Distinct. When we are examining data in a table, it can be helpful to know what distinct values exist in a particular column. Distinct is used to return unique values in the output. It filters out all duplicate values in the specified columns. For instance, select tools from inventory might produce hammer, nails, nails, nails. By adding distinct before the column name, select distinct tools from inventory. The result would now be tools, hammer, nails. Filtering the results of a query is an important skill in SQL. It is easier to see the different possible genres in the movie table after the data has been filtered than to scan every row in the table. Let's try it out. In the code editor, type select distinct genre from movies. What are the unique genres? Action, comedy, horror, romance, drama. Now change the code so we return the unique values of the year column instead. Select distinct year for movies. Cool. Where. We can restrict our query results using the where clause in order to obtain only the information we want. Following this format, the statement below filters the results set to only include top-rated movies, IMDb ratings greater than 8. Select all from movies where IMDb rating is greater than 8. How does it work? The where clause filters the results set to only include rows where the following condition is true. IMDb rating greater than 8 is the condition. Here, only rows with a value greater than 8 in the IMDb rating column will be returned. The greater than is an operator. Operators create a condition that can be evaluated as either true or false. Comparison operators used with the where clause are equal to, not equal to, greater than, less than, greater than, equal to, less than, or equal to. There are also some special operators that we will learn more about in the upcoming exercises. Suppose we want to take a peek at all the not so well received movies in the database. In the code editor, type select all from movies where IMDb rating is less than 5. Damn. I like this movie, but I was a kid. Anyway, now retrieve all the recent movies, specifically those that were released after 2014. So select all from movies where year is greater than 2014, or like 1. Like can be a useful operator when you want to compare similar values. The movies table contains 2 films with similar titles, 7 with a 7 as the V and 7 as with spelled normally. How could we select all movies that start with SE and end with EN and have exactly one character in the middle? Select all from movies where name like SE_EN. Like is a special operator used with the where clause to search for a specific pattern in a column. Name like SE_N is a condition evaluating the name column for a specific pattern. SE_EN represents a pattern with a wildcard character. The underscore means you can substitute any individual character here without breaking the pattern. The names 7 and 7 both match this pattern. Let's test it out. In the code editor, type select all from movies where name like SE_EN. Cool. Like 2. The percentage sign is another wildcard character that can be used with like. This statement below filters the results set to only include movies with names that begin with the letter A. So select all for movies where name like A percent. Percent is a wildcard character that matches 0 or more missing characters in the pattern. For example, A% matches all movies with names that begin with letter A. Percent A matches all movies that end with A. We can also use percent both before and after a pattern. Select all for movies where name like percent man percent. Here, any movie that contains the word man in its name will be returned in the result. Like is not case sensitive. Batman and Man of Steel will both appear in the result of the query above. In the text editor, type select all from movies where name like percent man percent. How many movie titles contain the word man? A bunch of them. Let's try one more. Edit the query so that it selects all the information about the movie titles that begin with the word the or the. You might need a space in there. I see. Nice. Is null. By this point of the lesson, you might have noticed that there are a few missing values in the movies table. More often than not, the data you encounter will have missing values. Unknown values are indicated by null. It is not possible to test for null values with comparison operators such as equals and not equals. Instead, we will have to use these operators, is null, is not null, to filter for all movies with an IMDb rating. Select name for movies where IMDb rating is not null. Now let's do the opposite. Write a query to find all the movies without an IMDb rating. So select only the name column. So select name from movies where IMDb rating is null. Between. The between operator is used in a where clause to filter the result set within a certain range. It accepts 2 values, that are either numbers, text, or dates. For example, this statement filters the result set to only include movies with years from 1990 up to and including 1999. Select all for movies where year between 1990 and 1999. When the values are text, between filters the result set for within the alphabetical range. In this statement, between filters the result set to only include movies with names that begin with either the letter A up to but not including ones that begin with J. So select all for movies where name between A and J. However, if a movie has a name of simply J, it would actually match. This is because between goes up to the second value, up to J. So the movie name J would be included in the result, but in the result set, but not Jaws. Using using the between operator, write a query that selects all information about movies whose name begins with the letters D, E, and F. Select all from movies where name between D and ABCDEF. Select all information about movies whose name begins, so ABCDEFG. Using the between operator, write a new query that selects all information about movies that were released in the 1970s. So we're named between 1970 and 1980, and we'll change name to year. Oh yeah, true. And sometimes we want to combine multiple conditions in a where clause to make the result set more specific and useful. One way of doing this is to use the AND operator. Here we use the AND operator to only return 90s romance movies. Select all for movies where year between 1990 and 1999 and genre equals romance. Year between 1990 and 1999 is the first condition. Genre equals romance is the second condition, and combines the two conditions. With and, both conditions must be true for the row to be included in the result. In the previous exercise, we retrieved every movie released in the 1970s. Now let's retrieve every movie released in the 70s that's also well received. In the code editor, type select all from movies where year between 1970 and 1979 and IMDb rating greater than 8. Remove the previous query. Suppose we have a picky friend who only wants to watch old horror films using AND. Write a new query that selects all movies made prior to 1985 that are also in the horror genre. So where year is less than 1985 and genre equals horror. Or, similar to AND, the OR operator can also be used to combine multiple conditions in where, but there's a fundamental difference. AND operator displays a row of, okay, I get it. It's like there's a certain point where this stuff is pretty simple, you know? So year is greater than 2014, or the genre is action. Suppose we were in the mood for a good laugh or a good cry. Using or, write a query that returns all movies that are either a romance or a comedy. So genre equals romance, or genre equals comedy. Genre. Order by, so select name, year, movies, order by name, alphabetical order for name. Your turn. Remove the previous query, write a new query that retrieves the name, year, and IMDb rating. So name, year, IMDb rating. From movies ordered highest to lowest by their ratings. So order by IMDb rating. Is it descending or desk? Yeah. What did I do wrong? Select name, year, IMDb rating for movies. Curious. Okay, maybe I should read it then. We can sort using order by. Sometimes we want to sort things in decreasing order. For example, if we want to select all of the well-received movies, highest to lowest by year, order by always goes after where, if where is present. So selects name, year, IMDb rating for movies. Order, oh. Cool. Limit. We've been working with a fairly small table, fewer than 250 rows, but most SQL tables contain hundreds of thousands of records. In those situations, it becomes important to cap the number of rows in the result. For instance, imagine that we just want to see a few examples of records. Select all for movies, limit 10. Limit is a clause that lets you specify the maximum number of rows the result set will have. This saves space on our screen and makes our queries run faster. Here we specify that the result set can't have more than 10 rows. Limit always goes at the very end of the query. Also, it is not supported in all SQL databases. Combining your knowledge of limit and order by, write a query that returns the top 3 highest rated movies. Select all the columns. So, oh wait, I don't need to do that. So what are we doing? Combining your knowledge of limit and order by. Select a query that returns the top 3 highest rated movies. So select all the columns. So select all from movies where we'll just do order by IMDb rating, descending order, and limit 3. Dark Knight, Inception, and Star Wars Episode 5. Great movies. Except for Inception. It's cool, but it's like, I don't know. Case. A case statement allows us to create different outputs, usually in the select statement. No, Inception's good. A case statement allows us to create different outputs, usually in the select statement. It is SQL's way of handling if-then logic. Suppose we want to condense the ratings in movies to 3 levels. If the rating is above 8, then it is fantastic. If the rating is above 6, then it is poorly received, else avoid at all costs. Select name, case. When IMDb rating is greater than 8, then fantastic. When IMDb rating is greater than 6, then poorly received, else avoid at all costs. And for movies. Each when tests a condition in the following then gives us the string if the condition is true. The else gives us the string if all the above conditions are false. The case statement must end with end. In the results, you have to scroll right because the column name is very long. To shorten it, we can rename the column to review using as. So select name, case, when IMDb rating greater than 8, then fantastic. When IMDb rating greater than 6, then poorly received, else avoid at all costs, and as review for movies. So let's try one on our own. Select the name column. Are we doing all? Or no, just name. Select name from movies. Case. I'll put this end down there. So select the name column and use a case statement to create the second column that is chill if genre. So when genre equals romance, then, oh, I see. Chill when genre equals comedy, then chill. Intense in all other cases, else intense. Oh, I thought they were making like a Netflix and chill joke. Optional, rename the whole case statement to mood using as. Give it your best shot. Create and return, so select. Oh, I do have to do this. A lot of intense. Review, congratulations. We just learned how to query data from a database using SQL. We also learned how to filter queries to make the information more specific and useful. Let's summarize. Select is the clause we use every time we want to query information from a database. As renames a column or table. Distinct return unique values. Where is a popular command that lets you filter the results of the query based on conditions that you specify. Like in between are special operators, and an or combines multiple conditions. Order by sorts the result. Limit specifies the maximum number of rows that the query will return. Case creates different outputs. Cool, cool, cool. How am I doing on time? Doing very, very well. How would you query all the unique genres from the books table? Select select unique genres from books. Ooh, distinct, not unique. It hurts. Select distinct genres from books. What code would you add to this query to place the colors in reverse alphabetical order? Z through A by name. Select all from colors, order by name. And we want them in reverse alphabetical order. So Z to A, so that'd be desk. What is the correct way to select only the cities with temperatures less than 35? Select all from cities where temperature is less than 35. Find the error in this code. Select name, case when IMDb rating greater than 8, then Oscar. When IMDb rating greater than 7, then good. When IMDb rating greater than 6, then fair. The column was not renamed. Missing the end statement. Which operator would you use to query values that meet all conditions in a where clause? And which of the following is not a comparison operator in SQL? Tilde. What does the wildcard character % in the following SQL statement do? Matches all sports that contain ball, matches all sports that begin with ball, matches all sports that end with ball. What is limit? A clause that is used to return unique values? Nope. A clause that lets you specify the maximum number of rows? Yes. Maximum columns. You should query in order to obtain all the information you want. What is like? A statement that allows us to create different outputs. Statement, select unique values. Statement used to bookmark columns. A special operator that can be used with the where clause, search for a pattern. What is order by? A clause that sorts the results set in alphabetical order only. Operator uses where clause sorts alphabetical numerically. What is the correct syntax to query both the name and date columns from the database? Select name, date. Is null condition returns true if the field has no value. Cool. Don't want to do this. What's the next steps? Aggregate functions. I guess I should do this. I should do this. The role that I'm interviewing for today is very SQL appreciative, I'll say. So just brushing up my knowledge, and it's within my time frame anyway, so it's fine. Introduction. SQL queries don't just access raw data, they can also, let me wait. Just want to make sure I didn't mess up the mic there. Doesn't look like it, but I'm just gonna check. 1, 2. Alright, cool. So good. SQL queries don't just access raw data, they can also perform calculations on the raw data to answer specific data questions. Calculations performed on multiple rows of a table are called aggregates. In this lesson, we have given you a table named Fake Apps, which is made up of fake mobile applications data. Here is a quick preview of some important aggregates that we will cover in the next 5 exercises. Count counts the number of rows. Sum, the sum of the values in a column. Max and min, the largest, smallest value. Average, the average of the values in a column. Round, rounds the values in the column. Before getting started, take a look at the data in the Fake Apps table. In the code editor, type select all from Fake Apps. What are the column names? ID, name, category, downloads, price. Count. The fastest way to calculate how many rows are in a table is to use the count function. Count is a function that takes the name of a column as an argument and counts the number of non-empty values in that column. So select count all from table name. Here we want to count every row, so we pass asterisk as an argument inside the parentheses. Let's count how many apps are in the table. In the code editor, run, select count all from Fake Apps. So 200 rows. Add a where clause in the previous query to count how many free apps are in the table. So select count all from Fake Apps, where price equal to 0. Sum. SQL makes it easy to add all values in a particular column using sum. Sum is a function that takes the name of a column as an argument and returns the sum of all the values in that column. What is the total number of downloads for all of the apps combined? Select sum downloads from Fake Apps. This adds all values in the downloads column. Let's find out the answer in the code editor. Type select sum downloads from Fake Apps. Whoa. Max min. The max min functions return the highest and lowest values in a column respectively. How many downloads does the most popular app have? Select max downloads from Fake Apps. The most popular app has 31,090 downloads. Max takes the name of a column as an argument and returns the largest value in that column. Here we return the largest value in the downloads column. Min works the same way, but it does the exact opposite. It returns the smallest value. So select min downloads from Fake Apps. Delete the previous query. Write a new query that returns the price of the most expensive app. So I'm not going to delete it. Max price from Fake Apps. Cool. Average. SQL uses the average function to quickly calculate the average value. So just go select average downloads from, I know I misspelled it there, Fake Apps downloads. Remove the previous query. Write a new query that calculates the average price for all the apps in the table. Select average price. Cool. Round. Let's just do it. So we're returning the name column and a rounded price column. In the code editor, type select name and round price to 0 decimals from Fake Apps. Remove the previous query. In the last exercise, we were able to get the average price of an app. So wait, just to be clear. It's the number of decimal places. Okay, cool. That's what I thought. Here we pass the price and integer zeros arguments. Go around the values the 0 decimal places. Remove the previous query. In the last exercise, we were able to get the average price of an app. This using this query. So select average price. Now let's edit this query so that it rounds this result to 2 decimal places. So select name. So select average price. And then we want to take this and round it to 2. Group by 1. Oftentimes, we will want to calculate an aggregate for data with certain characteristics. For instance, we might want to know the mean IMDb ratings for all movies each year. We could calculate each number by a series of queries with different where statements like so. Select average IMDb rating for movies where year equals 1999. Select average IMDb rating for movies blah blah blah, and so on. Luckily, there's a better way. We can use group by to do this in a single step. Select year, average IMDb rating for movies, group by year, order by year. Group by is a clause in SQL that is used with aggregate functions. It is used in collaboration with the select statement to arrange identical data into groups. The group by statement comes after any where statements, but before order by and limit. In the code editor, type select price count all from fake apps group by price. Here our aggregate function is count, and we arranged price into groups. What do you expect the result to be? So we're selecting price and the count all from fake apps and grouping by price. So for each price, we're going to get a count of how many apps are at that price. In the previous query, add a where clause to count the total number of apps that have been downloaded more than 20,000 times at each price. So select price, count all from fake apps. The group by statements come after any where statements, but before order by and limit. So where, what? Price, where downloads, download more than 20,000 times. Remove the previous query, whatever. Write a new query that calculates the total number of downloads for each category. Category, some downloads from fake. Write a new query that calculates the total number of downloads for each category. Select category and some downloads. So select category, some downloads from fake apps, and group by category. Group by 2. Sometimes you want to group by a calculation done on a column. For instance, we might want to know how many movies have IMDb ratings that round to 1, 2, 3, 4, 5. We could do this using the following syntax. Select round, IMDb rating, count name for movies, group by round, IMDb rating, order by round, IMDb rating. However, this query may be time consuming to write and more prone to error. SQL lets us use column references in our group by that will make our lives easier. 1 is the first column selected, 2 is the second column selected, 3 is the third column selected, and so on. The following query is equivalent to the one above. Select round IMDb rating, count name from movies, group by 1, order by 1. Here the 1 refers to the first column in our select statement, round IMDb rating. Suppose we have the query below. Select category, price, average downloads from fake apps, group by category price. Write the exact query but use column reference numbers instead of column names after group by. So we want to select category, price, and average the downloads from fake apps, group by category, price. Write the exact query but use column reference numbers instead of column names after group by. So that's 1, 2. Having, in addition to being able to group data using group by, SQL also allows you to filter which groups to include and which to exclude. For instance, imagine that we want to see how many movies of different genres were produced each year, but we only care about years and genres with at least 10 movies. We can't use where here Because we don't want to filter the rows, we want to filter groups. This is where having comes in. Having is very similar to where. In fact, all types of where clauses you learned about this far can be used with having. We can use the following for the problem. Select year, genre, count name for movies, group by 1, 2, having count name greater than 10. When we want to limit the results of a query based on values of the individual rows, use where. When we want to limit the results of a query based on an aggregate property, use having. So again, when we want to limit the results of a query based on values of the individual rows, use where. When we want to limit the results of a query based on an aggregate property, use having. Having statement always comes after group by, but before order by and limit. Suppose we have the query below. Select price, round, average downloads, count all from fake apps group by price. It returns the average downloads rounded and the number of apps at each price point. However, certain price points don't have very many apps, so their average downloads are less meaningful. Add a having clause to restrict the query to price points that have more than 10 apps. So select price, round, average downloads, count all from fake apps group by price, having have more price points have more than 10 apps. So select price and round the average downloads. So we don't just look at the price, look at the rounded average, so essentially just the average downloads associated with that price point and the count, but we want to restrict the query to price points that have more than 10 apps, having I forget the database schema, so first of all I'm just gonna, what is it again? Price, downloads, category, name, ID. So I guess we want things where the count is greater than 10. No. So you have to include this. Oh wait, no, can I do this? No, you can't. Boom, 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 boom. Review. Congratulations, you just learned how to use aggregate functions to perform calculations on your data. What can we generalize so far? Count the number of rows, sum, the sum of the values in a column, max min, the largest smallest value, average, the average of the values in a column, round the values in the column. Aggregate functions combine multiple rows together to form a single value of more meaningful information. Group by is a clause used with aggregate functions to combine data from one or more columns. Having, limit the results of a query based on an aggregate property. Cool. Feeling good, feeling great. What does the count function take as arguments? So count the name of a column or asterisk, the name of a table, the name of a database. What's this? What does the following query do? Select price, count all from menu where orders greater than 50, group by price. So we have the price column and a count column. From our menu table, we're looking at only the orders where, or only the ones with more than 50 orders. Calculates the total number of menu items that have been ordered more than 50 times. Calculates the total number of menu items that have been ordered more than 50 times sorted by price. Calculates total menu items. Calculates total menu items ordered more than 50 times for each price. Oh my. For each price. We're grouping by price. Calculates total number of menu items that have been ordered more than 50 times for each price. That makes sense. What does the round function take as as arguments? The column name, and the number of decimal places to round the values in the column 2. Find the error in this code. Select count all from songs having plays greater than 100. So select count all from songs having plays greater than 100. Yeah. What does the following query do? Select genre and sum downloads from Kindle, group by genre. Returns the total amount of downloads for each genre. Yeah. What does the following query do? Select neighborhood, average price from apartments, group by neighborhood. It calculates the average price of apartments in each neighborhood. Calculates the highest, total, or lowest. Which function takes a column and returns the total sum of the numeric values in that column? How would you calculate the minimum number of stops from the train table? Select min stops. The where clause filters rows, whereas the having clause filters groups. Aggregate functions count the number of rows where the value is not null. Cool. Well, this is interesting. Hacker News is a popular website run by Y Combinator. It's widely known by people in the tech industry as a community site for sharing news, showing off projects, asking questions, among other things. In this project, we'll be working with a table named Hacker News. It contains stories from Hacker News since its launched in 2007. That's pretty cool. Wonder where this data set is available. Anyway, don't get distracted. How long is this going to take? Multiple tables. Yeah, I should probably do this. See how much I can get done within the next 40 minutes at least. Introduction. So, in order to efficiently store data, we often spread related information across multiple tables. For instance, imagine that we're running a magazine company where users can have different types of subscriptions to different products. Different subscriptions might have many different properties. Each customer would also have lots of associated information. We could have one table with all of the following information: order ID, customer name, and so on. However, a lot of this information will be repeated. If the same customer has multiple subscriptions, that customer's name and address will be reported multiple times. If the same subscription type is ordered by multiple customers, then the subscription price and subscription description will be repeated. This will make our table big and unmanageable. So instead, we can split our data into 3 tables. Orders would contain just the information necessary to describe what was ordered. So order ID, customer ID, subscription ID, purchase date. Subscriptions would contain the information to describe each type of subscription. Customers would contain the information for each customer. In this lesson, we'll learn the SQL commands that will help us work with data that is stored in multiple tables. Examine these tables by pasting the following code into the editor. Table. Cool. Combining tables manually. Let's return to our magazine company. Suppose we have the 3 tables described in the previous exercise shown in the browser on the right. We are going to try something new. Orders, subscriptions, customers. If we just look at the orders table, we can't really tell what's happened in each order. However, if we refer to the other tables, we can get a complete picture. Let's examine the order with an order ID of 2. It was purchased by the customer with a customer ID of 2. To find out the customer's name, we look at the customers table and look for the item with a customer ID value of 2. We can see that customer 2's name is Jane Doe and that she lives at 456 Park Avenue. Doing this kind of matching is called joining 2 tables. Using the tables displayed, what is the description of the magazine ordered in ID 1? So, ID 1, subscription ID is 3, and for subscription ID 3, sports magazine. Type your answer on line 1 of the code editor. Be sure to capitalize it, the same as in the table. using the tables displayed, what is the customer name of the customer in order ID number 3? So order ID 3, customer ID 3, Joe Schmo. Combining tables with SQL. Combining tables manually is time consuming. Luckily, SQL gives us an easy sequence for this. It's called a join. If we want to combine orders and customers, we would type select all from orders, join customers on orders.customer ID equals customers.customer ID. Let's break down this command. The first line selects all columns from our combined table. If we only want to select certain columns, we can specify which ones we want. The second line specifies the first table that we want to look in, orders. The third line uses join to say that we want to combine information from orders with customers. The fourth line tells us how to combine the two tables. We want to match orders, tables, customer ID column with customers, tables, customer ID column. Because column names are often repeated across multiple tables, we use the syntax table name.column name to be sure that our requests for columns are unambiguous. In our example, we use the syntax in the on statement, but we will also use it in the select or any other statement where we refer to column names. For example, instead of selecting all the columns using asterisk, if we only want to select orders, tables, the orders tables, order ID column, and the customers tables, customer name column, we can use the following query. Select orders.order_ID, customers.customer_name, from orders, join customers on orders.customer_ID equals customers.customer_ID. So join the orders table and subscriptions table and select all columns. Make sure to join on the subscription ID column. So select all from orders, join customers on orders dot subscription ID equals subscription subscription ID subscriptions dot subscription ID. Cool. Don't remove the previous query. Add a secondary query after your first one that only selects rows from the join where description is equal to fashion magazine. Oh, wait, why does it want me to? Whatever. Guess it wants me to just type it again. Select all from orders, join subscriptions on orders.subscription ID equals subscriptions.subscription ID where description equals fashion magazine. Remove every first one only says rows. Oh, you know what it probably was? This. Inner joins. Let's revisit how we joined orders and customers. For every possible value of customer ID in orders, there was a corresponding row of customers with the same customer ID. What if that wasn't true? For instance, imagine that our customers table was out of date and was missing any information on customer 11. If that customer had an order in orders, what would happen when we join the tables? When we perform a simple join, often called an inner join, our result only includes rows that match our on condition. Consider the following animation, which illustrates an inner join of two tables on table 1.c2 equals table 2.c2. The first and last rows have matching values of C2. The middle rows do not match. The final result has all values from the first and last rows, but does not include the non-matching middle row. Suppose we are working for the Codecademy Times, a newspaper with two types of subscriptions: print newspaper, online articles. Some users subscribe to just the newspaper, some subscribe to just the online edition, and some subscribe to both. There's a newspaper table that contains information about the newspaper subscribers. Count the number of subscribers who get a print newspaper using count. So select count all from subscribers. I forget the schema again. Let's just see all of it. Select all subscribers. All from newspaper. I should really read more. There is a newspaper table that contains information about the newspaper subscribers. Count the number of subscribers who get a print newspaper using count. Don't remove your previous query. There is also an online table that contains information about the online subscribers. Count the number of subscribers who get an online newspaper using count. Don't remove your previous queries. Join the newspaper table and online table on their ID columns, the unique ID of the subscriber. How many rows are in this table? So how you do it? So select count from newspaper, join online. On newspaper.id online.id. Do you want me to count all the rows of online joined with newspaper? I thought I did. What am I missing? Oh. Left joins. What if we want to combine two tables and keep some of the unmatched rows? SQL lets us do this through a command called left join. A left join will keep all the rows from the first table, regardless of whether there is a matching row in the second table. Consider the following animation. The first and last rows have have matching values of C2. The middle rows do not match. The final result will keep all rows of the first table, but will omit the unmatched row from the second table. This animation represents a table operation produced by the following command. Select all from table 1, left join table 2 on table 1.c2 equals table 2.c2. The first line selects all columns from both tables. The second line selects table 1, the left table. The third line performs a left join on table 2, the right table. The fourth line tells SQL how to perform the join by looking for matching values in column C2. Let's return to our newspaper and online subscribers. Suppose you want to know how many users subscribe to the print newspaper, but not to the online. Start by performing a left join of newspaper table and online table on their ID columns, selecting all columns. So select all from newspaper, join online on newspaper.id equals online. Select all from newspaper, left join online on, oh, why is it finicky like that? Don't remove your previous query. In order to find which users do not subscribe to the online edition, we need to add a where clause. Add a second query after your first one. That adds the following where clause and condition. This will select rows where there was no corresponding row from the online table. Primary key versus foreign key. Let's return to our example of the magazine subscriptions. Recall that we had three tables: orders, subscriptions, and customers. Each of these tables has a column that uniquely identifies each row of that table. Order ID for orders, subscription ID for subscriptions, customer ID for customers. These special columns are called primary keys. Primary keys have a few requirements. None of the values can be null. Each value must be unique, i.e. you can't have two customers with the same customer ID in the customer's table. A table cannot have more than one primary key column. So again, I understand. Note that customer ID, the primary key for customers, and subscription ID, the primary key for subscriptions, both appear in this. When the primary key for one table appears in a different table, it is called a foreign key. So customer ID is a primary key when it appears in customers, but a foreign key when it appears in orders. In this example, our primary keys all had somewhat descriptive names. Generally, the primary key will just be called ID. Foreign keys will have more descriptive names. Why is this important? The most common types of joins will be joining a foreign key from one table with the primary key from another table. For instance, when we join orders and customers, we join on customer ID, which is a foreign key in orders and the primary key in customers. Suppose Columbia University has two tables in their database. The classes table contains information on the classes that the school offers. Its primary key is ID. The students table contains information on all students in the school. Its primary key is ID. It contains the foreign key, class ID, which corresponds to the primary key of classes. Perform an inner join of classes and students using the primary and foreign keys described above, and select all the columns. So select all from, has two tables in the database. Classes contains information on classes that the school offers. Its primary key is ID. The students table contains information on all the students in the school. Its primary key is ID. It contains the foreign key class ID, which corresponds to the primary key of classes. Perform an inner join classes and students on classes.id equals students.class ID. Cross join. So far we focused on matching rows that have some information in common. Sometimes we just want to combine all rows of one table with all rows of another. For instance, if we had a table of shirts and a table of pants, we might want to know all the possible combinations to create different outfits. Our code might look like this. Select shirts.shirtColor, pants.pantsColor. From shirts, cross join pants. The first two lines select the columns shirt color and pants color. The third line pulls data from the table shirts. The fourth line performs a cross join with pants. Notice that cross joins don't require an on statement. You're not really joining on any columns. We have 3 different shirts, white, gray, and olive, and 2 different pants, light denim and black. The results might look like this. 3 shirts, 2 pants is 6 combinations. This clothing example is fun, but it's not very practically useful. A more common usage of cross join is when we need to compare each row of a table to a list of values. Let's return to our newspaper subscriptions. This table contains 2 columns that we haven't discussed yet. Start month, the first month where the customer subscribed to the print newspaper, i.e. 2 for February, and end month, the final month where the customer subscribed to the print newspaper. Suppose we wanted to know how many customers were subscribed during each month of the year. For each month, 1, 2, 3, we would need to know if a user was subscribed. Follow the steps below to see how we can use a cross join to solve this problem. Eventually, we'll use a cross join to help us, but first let's try a simpler problem. Let's start by counting the number of customers who were subscribed to the newspaper during March. Use count all to count the number of rows, so select count all. Count the number of rows in a where clause, so select all from newspaper where to restrict to conditions for start month less than or equal to 3 and end month is greater than or equal to 3. Don't remove the previous query. The previous query lets us investigate 1 month at a time. In order to check across all months, we're going to need to use a cross join. Our database contains another table called months, which contains the numbers between 1 and 12. Select all columns from the cross join of newspaper and months. Select all from newspaper, join months. Don't remove your previous queries. Create a third query where you add a where statement to your cross join to restrict to 2 conditions. So where start month is less than or equal to month and end month is greater than or equal to month. This will select all months where user was subscribed. Don't remove your previous queries. Create a final query where you aggregate over each month to count the number of subscribers. Fill in the blanks in the following query. So we're going to select month, count all from newspaper, cross join months, where start month is less than month, and we're going to group by count all, or no, sorry, apologies. So select month, union. Sometimes we just want to stack one data set on top of the other. Well, the union operator allows us to do that. Suppose we have 2 tables and they have the same columns. Table 1, Pokemon Bulbasaur, Charmander, Squirtle, type grass, fire, water. Table 2, Snorlax, type normal. If we combine these 2 with union, select all from table 1, union, select all from table 2. The result will look like this. SQL has strict rules for appending data. Tables must have the same number of columns. The columns must have the same data types in the same order as the first table. Let's return to our newspaper and online subscriptions. We'd like to create one big table with both sets of data. Use union to stack the newspaper table on top of the online table. So select all from newspaper union, select all from online. With, oftentimes we want to combine two tables, but one of the tables is the result of another calculation. Let's return to our magazine order example. Our marketing department might want to know a bit more about our customers. For instance, they might want to know how many magazines each customer subscribes to. We can easily calculate this using our orders table. Select customer ID, count subscription ID as subscriptions, from orders, group by customer ID. This query is good, but a customer ID isn't terribly useful for our marketing department. They probably want to know the customer's name. We want to be able to join the results of this query with our customers table, which will tell us the name of each customer. We can do this by using a with clause. With previous results as, select this, select all from previous results, join customers on this equals this, so the with statement allows us to perform a separate query, such as aggregating customer subscriptions. Previous results is the alias that we will use to reference any columns from the query inside of the with clause. We can then go on to do whatever we want with this temporary table, such as join the temporary table with another table. Essentially, we are putting a whole first query inside the parentheses and giving it a name. After that, we can use this name as if it's a table and write a new query using the first query. Place the whole query below into a with statement inside parentheses and give it the name previous query. So what is it with previous query as? Select customer ID, count subscription ID as subscriptions from orders, group by customer ID, join the temporary table previous query with customers table, and select the following columns. So that looks like select all from previous query, join the temporary table previous query with customers. So join customers on customers.customer name on customers.customer ID equals previous query dot customer ID, and we're not selecting all, we're selecting customers, customer name, previous query dot subscriptions. What's the discrepancy? So with let's just it's an indentation issue. Give me that. Review. In this lesson, we learned about relationships between tables and relational databases and how to query information from multiple tables using SQL. Let's summarize what we've learned so far. Join will combine rows from different tables. If the join condition is true, left join will return every row in the left table. And if the join condition is not met, null values are used to fill in the columns from the right table. Primary key is a column that serves a unique identifier for the rows in the table. Foreign key is a column that contains the primary key to another table. Cross join lets us combine all rows of one table with all rows of another table. Union stacks one data set on top of another. With allows us to define one or more temporary tables that can be used in the final query. Nice, nice, nice. Over time, how am I doing on the syllabus? So I'm actually looking pretty good. I'm just gonna read this then, I guess, and finish this. Definitely need to get my multiple tables skills up. In a left join, if a join condition is not met, what will it use to fill columns on the right table? Null values. Why is a cross join not so useful? It combines every row in one table with every row in another table. Union allows us to stack one data set on top of another. True. What kind of join is in the animation below? So it's saying these two rows. So, okay, repeat it, please. Can you run it back, please? Rewind. Okay. I guess not. So it definitely wasn't a cross join. It seemed like, here, can I reload it? No. Don't do that yet. In a left join, if a join condition is not met, what will it use to fill columns on the right side? Null values. Sorry, that pissed me off. What is the best definition of a foreign key? A unique identifier for each row record in a given table. A column that contains the primary key of another table in the data set. Okay, so A, Q, X, C2, B, W, Y, C2, B, something Y, C3, B, C, Z. This seems to me like it took the fact that each of these tables had a column called C2, and it only made the ones where they have the same value, so that's an inner join. Correct. When we perform a simple join, often called an inner join, our result only includes rows that match our on condition. What is the difference between an inner join and a left join? A left join combines rows from two or more tables, but unlike inner join, it does not require the join condition to be met. A left join is an obsolete. No. An inner join is no. An inner join joins rows within a table. No, it's this. Why is a cross join not so useful? Combines every row in one table with every row in another table. You have two tables, teachers and students. Each student belongs to a teacher. Complete the query to join the tables on the teacher ID. So select all from students. Join teachers on. So students.teacherID equals teachers.id. Which keyword would you use to alias recipe's name as in the following query? So union allows us to stack one data set on top of another. True. What is the best definition of a primary key? A unique identifier for each row or record in a given table. You have two tables, authors and books. Each book belongs to an author and references that author through a foreign key. If the primary key of the author's table is ID, what would be the most sensible name for a foreign key in the books table? That references ID column in the author's author ID. Nice. Next steps. You successfully completed this. Did the journey. So again, congratulations. All right, cool. So now